We've got a small shop air compressor we've been using as a backup source of instrument air in our lab for a few years. This used to be our primary air compressor years ago when we were in a much smaller building, but now I've been using it as a backup air compressor just in case the main one fails. A few years ago we put a PLC control on it just for fun, and it's worked out quite well, but we're redoing the PLC control now to go with an Allen Bradley and just to have more experience in fabricating systems. So we're looking right now at the panel we're building for this. Here's new Allen Bradley SLC 500 PLC. It's got a 503 processor, analog input card, DC syncing input, discrete output card. We're going to be using this to control the compressor, turning it on and off. The main information coming in about the air pressure comes from this 4 to 20 milliamp pressure transmitter. That will send a 4 to 20 milliamp analog signal into the analog card. The PLC will then read that analog value, compare it with a pair of trip points, high and low, and determine whether to latch the compressor motor on and off. We also have an input card that's discrete. We're going to be using this to measure a switch, a high pressure switch, and using that to shut down the compressor just in case we have a failure in our transmitter and we lose our air pressure signal. We'll have another way to tell what the air pressure is in a discrete form. We also have a discrete output card, triac output. This is going to drive AC power to the coil of our main contactor, which then drives 120 volt power to the compressor motor. So again, this is really throwing way more technology at this project than we have to. It's a gratuitous use of instrumentation. But you know what? It's fun. And we can do it, and we learn a lot by doing it. So it's a practical project, getting that little air compressor to be controlled by a PLC. That's worth many times the value of the compressor. But the value here really is not the monetary, but it's the learning that we get out of this. And that's the whole point. So this team is going to be installing this system into an enclosure, which is sitting over here. The enclosure is going to have a HMI panel on the front where you get to change the high and low pressure trip points. We get to monitor things about the compressor like temperature. You'll notice here in the subpanel we also happen to have a temperature transmitter. We'll be monitoring the cylinder head temperature of that compressor, and if it gets too hot, the PLC can shut the compressor down for the compressor's sake to keep it from being overloaded. That's especially pertinent because this compressor is fairly small for the surfaces being pressed into. Using it as a backup, it is entirely possible we could overload it. So I want to make sure that this system is well aware of the condition of that compressor and shuts it down before we burn anything up. So again, fun project, lots of learning to be had here. That's what we're here for.